Hey, and welcome to this short tutorial on Docker. In this tutorial, we will talk about what Docker is and why use it. And then after that, we will get our hands dirty and create our own image and run it. And in that process, we will also look at some basic commands of Docker. So let's dive in. There was a long time ago when software was deployed by copying it to a pre-configured server. While it worked, it had a lot of problems. If the server was not configured properly, for example, there was a library missing or had a wrong version, the software would not run. It also meant that to scale horizontally, you would have to create an almost exact copy of that server, including all the dependencies, which is not an easy task. Then came containers. It is a way to package your software with all its dependencies and its runtime. Because the dependencies and the runtime is predefined, it is guaranteed that the software will run without any problems. And if you need to horizontally scale your application, all you need to do is duplicate your container. Containers run on something called Container Engine. Docker is the most famous and common standard used in the industry today. The logo of Docker explains the concept of Docker Engine beautifully. The ship in the shape of a whale is the Docker Engine, and the containers are the Docker images running on that engine. Before we dive into more theory like advantages of using container, let's get our hands dirty and see how Docker works, create our own image and run it. For the purpose of this tutorial, I'll assume that Docker is already installed on your machine. Like all programming languages, Docker also provides an hello world example. You can run it by running the command docker run hello-world. This command will pull the image from the Docker Hub and then prints a message hello from Docker. We already looked at our first Docker command. Docker run runs a container from an image. Let's look at our second command, which is docker images. As you can assume correctly, this will show you all the images that your Docker has. Right now we only have one image, hello world, which we just ran to test if our Docker is installed properly. The next command we should look at is docker ps. This command will print all the running containers. We right now do not have any running containers, but you can also run this command with an extra flag -a, which will print all the containers, including the ones that have already stopped. Now that we know some basic Docker commands, let's move on to the fun part, which is creating our own image. To create our own image, we first need our software. For the purpose of this tutorial, I have created a very simple Go program. Even if you do not have any experience with Go, the program is very simple to follow. This program creates a web server in line number 10. And in line number 14, this program runs the web server. In line number 12, this program exposes the default endpoint / and says that the method say hello to the world should process this call. The method say hello to the world prints out a simple hello world string and sends the status back OK, which is 200. Let's run this program to see if it is running as expected. Once I run my program, my web server is started and running on port 8080. If I direct my browser now to port 8080, I can see the string hello world printed. Now that we have a working software, let's create a Docker image. To create the Docker image, we need a file called Dockerfile. Dockerfile defines the steps that are needed to convert the software into an image. Let's go through these steps step by step. Line number 3 is the first step where we define the base image that we will use to create our own image. Think of the base image as the operating system in which your software will run. You can download this base image from Docker Hub. Docker Hub also provides official base images for every language. So it doesn't matter if you program in Java, JavaScript or Python or C, you will find a base image for your software. Let me correct myself. You do not have to download the base image manually. When you run the Docker command with this Docker file, the base image will be downloaded automatically for you. Moving on, let's look at line number 6. This defines a work directory. This is where all the commands that come after this line will run into. Think of it as doing a CD on your server and you CD into your /app directory. Let's move on to the next line. Line number 9 and line number 10 are Go language specific. These commands basically download all the dependencies that I need to run my Go software. The next line, line number 14, copies my Go software to the app directory. In this case, which is just hello-world.go file. Line number 17 is also very Go specific. Here I create a binary out of my software. Once I have my binary file, which is the hello world file, line number 27 issues the command that will run inside my container, inside my operating systems defined by the base image in the directory /app. Let's go through the Docker file once more to make sure we understood everything. So first you define your operating system. Then you define the directory in this operating system where you will work. After that, you download all the dependencies. And then you copy your software into this working directory. After that, you run your language specific commands using the run command. Once you have done that and you have the final software, you have to give the command using the cmd and say how to run this inside this container. Now that we have our software and the Docker file prepared, we can copy these files to our server where Docker is running. Next, we will build our new Docker image using the command docker build. With the option -t, you can give a human readable name or a tag to this image. The dot says that use the Docker file that you find in the current directory. Once I run my command, the Go base image will be downloaded from GoHub, and all the steps that we mentioned before in the doc file will be executed step by step. After the docker build command finishes successfully, you can use the command docker image ls or docker images to see the newly created image. Now we can run the newly created image using the command docker run. You will notice two new parameters here, -t and -p. -t basically tells Docker to run the image in detached mode, and -p will forward the port from this machine to the port in the running container so that we can access the services running in the container from the outside world. Once my container is running, I can check out the running container using the command docker ps. You can see that the new container hello world was started about 17 seconds ago. We can see the logs of the running container using the command docker logs and ID of the container. You can see that the web server started and is listening on port 8080. We can test it using the command curl localhost 8080, which as expected prints the string hello world. To stop a running container, you can use the command docker stop and the ID of the container. After that, you can use the command docker ps to see that there are no running containers anymore. Congratulations on building and running your first Docker container. But there is still something that we can optimize. If you run the command docker images, you will see our image hello world. And if you check out the size, it's 1.21 gigabytes, which is huge to run such a simple hello world server. Why is that? The problem is that the base image that we downloaded has the infrastructure to build a Go program. To run the Go program, we don't need all this infrastructure. So we can actually use two images, one image to build our program and the second image to run our program. To do that, we can use Docker Compose. Docker Compose is a tool which helps us define and run multi-container applications. So let's go back to our Visual Studio where we had our Docker file and create a new docker.multistage file. Till line number 17, this docker.multistage file is almost similar to the Docker file. The only difference being that in line number 3, we give the set of commands a name, which is build stage. Starting from line number 20, we have a new stage which we call build release stage. Here we use the new image Debian Bookworm, which is a simple Linux server without any Go running infrastructure. After that, in line number 22, we define our work directory like we defined in our Docker file. Then we copy from our build stage, which we define in line number 3, the build application hello world into our working directory with the same name. We have to set some user rights, and then we just say entry point, which will tell us how to start this program in our build release stage. So again, the build multi-stage separates the build process and the run process. The build process runs an image which is pretty heavy and quite big because it needs all the building tools that Go needs, and the runtime just needs a normal Linux environment. So let's build our new Docker image with the command docker build. This time I will name it hello world 2. You will see a new parameter -f which will define the Docker file that is supposed to be used. Because in this case, we don't want to use our normal Docker file, but the newly created docker.multistage file. And the dot in the end basically says run this command here, so that's where the Docker file will be found. Once the build process is finished, we can run the command docker images to see that our new image hello world 2 has been created, and it's only 128 MB, which is like 10 times smaller than the hello world image. Let's run the newly created image using the docker run command. We can use the docker ps command to see the running container. We can use the docker logs and the ID of the container to make sure that our server is up and running. And then we can use the curl command to make sure that the hello world is printed as expected. Now that we know how to build and run Docker images, let's talk about the advantages of using Docker. The first advantage is that Docker is portable. Once you have your image created, you can move this image to any other place where the Docker engine is running, and you can run it using the Docker run command. So that way you can create an image in your test environment, and once the tests are successful, all you have to do is move this image to your production and run it there. Next, it is very easy to manage. You do not have to worry about dependencies, operating systems, or anything. To run an image, all you need is Docker engine. Also, Docker is more hardware efficient, so you can run multiple containers on a single Docker engine. Also, the containers are immutable. Once the container has been started, it cannot be changed. As the images are versioned, the state of the running system is guaranteed. That brings us to the end of our Docker tutorial. If you have any questions or comments, please leave them in the comments. Also, have fun creating your Docker images.